I got the panning station moved out from the side of the building here. It's up over there now. We'll put it to use somewhere else. And I also unloaded this from the trailer. But in the meantime, we're going to dismount the RP-4 shaker table from this tank. It uses up too much space to put up alongside the building, so we'll be bolting it down to a slab that I'll also need to frame in and pour. Now you might wonder why I keep the top of this thing covered up. The deck of the RP-4 is ABS plastic, and if you leave it in the sun it will warp, and it is irreplaceable. Nobody seems to sell replacement decks. Okay, I finally got the RP-4 shaker table out. Well, with some help. So, anyhow, now that we got it out, we'll drag this box out of the way and see if we can figure out where we're going to set it and get some measurements to put our slab in. Now these bolts holding the RP-4 shaker table down were pretty rusted, seeing as how this box had water in it. So I wound up having to use the old angle grinder and grind the heads off it. So grind the head off the bolt and whittle it down until it's flush with the foot. Then we had to use a pry bar to pry the remaining rust loose so we can lift the RP-4 out. And all in all, the RP-4 is pretty light. 2 guys, no problem. But the tank itself, that's got to be a couple hundred pounds. That thing's a monster. We have a little decay that we need to take care of. This leg is kind of rotted through, being as it sat in water. And also, the RP-4 table has the notoriety of vibrating up and down on this pin, so people strap it down, but this one is actually worn through, so we'll have to do a repair on that. So let's cut some metal. Well, that piece fits really nice, so we'll get it cleaned up here. Last time I checked, welding doesn't stick very well to rust, so in fact it just makes it spark and sputter a lot, makes your weld look even worse. We'll use the angle grinder and buff it up here, get a nice clean surface to work on. That's already looking good. Well, I've welded it on, and I'm going to hit it with some spray here. It's called Weld-Right spray. It improves the look of any weld and increases the strength by 1/100th of a tenth of a percent. It's also known as spray paint, but it does make the weld look better. Now let's get to work on this leg here. I'm going to weld on a couple of this flat iron. Couple of pieces. The leg was only rotted on these 2 sides. The other side seemed to be fairly structurally sound. And you see I'm welding here with this horrible freight welder. It's a wire feed welder. It's got a bad switch in the handle. or a bad wire somewhere along the line. It keeps cutting out. And yeah, it makes stuff stick together. And of course, once you're done welding, you go back over it with Mr. Grinder and clean it up. And if you see any pockets or cavities, you can go back and weld over that. Grind it down again, do some more welding and some more grinding, and then in the end you hit it with the magic spray that I showed you, and that's what it looks like. So we've got a leg here that should hold up for another couple of months at least. And here's the results of my repairs. I put a piece of metal on the bottom of the tank, or the trough there, to give it some structure. Being as this is just ABS, it's not very structurally sound, but you know, you don't plan on hitting it with a tractor, so this is what we do. We just mix up some JB Weld Clear and slather it on, get it in the cracks and the crevices. You'll notice I've mounted a better switch down there below the structure, just because I don't like getting electrocuted. I hate doing the 60 cycle shuffle. So I put on a waterproof switch. I don't plan on dunking it in water, but you know, it's another layer of safety. So we slather on the glue here, and we put on a couple clamps to hold it together. This is a kind of a tough repair, being that it's basically, if you do woodwork, it's called a butt joint. You're joining the edges of material together, so you don't have a lot of surface to work on. And I don't want to glue metal plates on everything, so yeah, we'll do what we can do. Now here's the material after it's all cured and the clamps have been removed. Looks pretty good. Holds water. And that's all we need. And now for a couple of hacks and mods. I added this 60-pound spring to hold the top of the shaker table down and prevent that bolt from bouncing up and down and wearing a hole through the plate again. A lot of people just strap it down, but I'm going to do a little better. And for the tailings outlet, I molded a piece of 1.5" ABS pipe and glued it into place. Now here's the original switch that was there before I put on the waterproof one. And in removing it, I found out that's where the start relay was hidden. And of course we're going to replace that. The start relay should be hanging vertical because it is gravity and electromagnetically actuated. If it's at an angle like this, it could lead to the contacts sticking closed and running the start windings continuously, which would burn out the start windings. Now here's the start relay, and the premise behind this is when you get a large current going through this coil, it will energize a secondary set of windings inside the motor, which will kick it to get it to start turning. Once it starts turning, the current drops, or the current through this coil drops, and it releases the relay. So I got the motor out. Actually it turns fairly well. The bearings aren't bad. Not a lot of in play. I hooked it up to a generator and was able to get it to run by putting power to it and then spinning the shaft to get it started, which means that the start windings are not activating. And looking inside here, the lacquer seems to be pretty much gone off most of these wires. There's some other places where the lacquer is still intact, but when you see shiny wires, that's usually a bad indication. So we'll replace this motor just to be on the safe side. No need in shorting out a motor and burning up a generator. Okay, here's our new motor for the shaker table. It's an old washing machine motor. There's the old one. You can see the windings are kind of bare. This one here, the windings have a good coat of lacquer on them. So this one, the old one's probably got some shorted windings. And it uses a start relay. It doesn't use a capacitor. So I need to figure out the wiring on this, get it wired up right so I don't smoke it. We're going to give it a bench test. I was watching Jeremy Fielding's channel, and he's got a lot of information on motors. So I've got it wired up. We're going to give it a test. Got it all plugged in. We'll flip on this switch, and it seems to run. Even starts on its own. So we're one step closer. I moved the rock crusher over here. It's going to be fed from our jaw crusher. It'll go down into our primary impact mill, then into our secondary flail mill. Then it'll come out the pipe down here into our sump, into a bucket, and we should have a good grind. Mineral liberation is the key, being that we're a hard rock mine, so we need to get our grinds down as fine as possible. We poured a 4-inch thick concrete pad for the impact mill, and hopefully that will hold it. We're putting a 6 horsepower Briggs & Stratton engine on it, similar to that one, and get it going. In the meantime, I was down talking to a guy that has lived up here for quite some time, and he had this S-cam from a crushing mill, from a stamp mill, sitting there on his assembly of rock crushing or ore crushing equipment. And I asked him about it, and he said, yeah, it was from my original stamp mill that was up here a long time ago, and that the scrappers had gotten it, and he got this out of the back of one of the trucks of the scrappers as a souvenir, and he gave it to me, so I brought it back up, and we're going to use this as an ornament. Unfortunately, I don't have enough parts to put the stamp mill back together yet, but that may come in time, or not. So this is where we're putting the pad for the RP-4. The bracket sitting on the ground there, that T-shaped thing, is holds the bolts in place for the RP-4. So we have a perfect alignment when we set the machine onto the bolts. And it actually worked out very well. Let's sneak up on the concrete workers and see how it's going.
Okay, bring it out. Big ass stash.
I caught you guys over here kibitzing.
Yeah.
Get to work. Oh, it's done.
We're union.
Okay, well, I laid out this concrete pad today. Well, this guy helped me. And this guy over here helped me. So, but we got this thing nailed out in, what, an hour and a half?
Yep.
A little under. We've got bolts mounted in the concrete for the shaker table mounts, and we've got bolts along the walls mounted in the concrete for holding up the walls, I hope. We got pipes sticking out of the ground, so it's up to code. Maybe. Now, once the concrete is set, we put the RP-4 onto the bolts. It slipped right on. Perfect fit. Couldn't have asked for better. A couple of shims under the feet, and we had it level. And we're going to give it a try out here. Of course, no water hooked up yet, but we got the electricity plugged in, and it runs real smooth. It doesn't jitter and jump around like it did without being mounted. When it wasn't mounted, that thing would get up and try walking away on you. So our next step is to put a roof over this thing and put some walls and doors on it and put it in use. Well, that's about it for today. Hope you enjoyed the tour. Complimentary refreshments will be served in the garden. And don't forget to visit the gift shop. See ya!